Hi everyone, welcome to today's video where we are going to be demonstrating how we can leverage Claude AI, specifically Claude 3.5 Sonnet, which is the latest model as of today, to create some advanced C++ classes and functionalities in Unreal Engine that can exponentially speed up your game development workflow. And for today's demonstration, we are going to be creating a turn-based battle system using hexagonal tile grid. We will be creating the hexagonal grid procedurally. We are also going to be using Paragon assets, which are perfect to demonstrate this kind of projects where you are having multiple different types of characters. You are going to understand how you can best use this amazing generative AI tool to speed up your Unreal Engine workflow. And of course, you have to know the basics of Unreal C++ programming to understand when it is making mistakes and when to correct its mistake. But even then, 90% of your development time will be cut down if you use this tool wisely. So without any further delay, let's get started. Alright, so you are looking into the Claude's homepage. You can start a new chat right away. If you are looking into different models, you can do that from here. The features which really work for me is this projects feature, because this is going to make sure that you don't have to create long chats over and over again. You can write a block of code, so you can save that as a file. When you want to modify that, you can simply start a new chat. You can already add your existing file separately inside the project, and that is the beauty of using this project section of Claude. And I love that I have so many projects already created, and I'm going to create another one for you right now. So let's click on this. I have the idea of creating. I am obsessed with turn-based games, and I have been already working with turn-based template, but now I want to see that something as complex as a hexagonal tile system, how good it is at creating that very easily for me. So let's do that. I will name this as turn-based game. All right. So you can describe your project, but that's not necessary. So let's start with my first chat. So let me write my prompt. Write a plugin in Unreal C++ for hexagonal tile battle system. I'm getting the codes written in separate window, although it is not that much useful over here as compared to when you are building something like a website where it is already giving you a preview of your website. Even with this, it is very useful because I can simply copy this, or I can also add this to my current project if I think that this is perfect. I don't have to manually add it. Obviously, that also I can show you over here. If you go to your project and you can add the content. So let's see the code right now. It has not created the C++ classes. So let me ask it to. Okay, it is creating the entire turn-based system also. Before I can go ahead and test the implementation of this turn-based system, I also need to first test the formation of the hexagonal tiles. So I will just ask it to keep it simplified and just focus on tiles. And before that, let's look into if the code and the logic it has created is correct. So this is a battle manager. So yeah, here is the hex tile. Initialize battlefield. It is asking for the width and height as parameters, and hex orientation and hex offset. So what exactly it is spawning? It is spawning a new actor of the type hex tile. So I will ask it to make some changes. Instead of hex tile actor, let all the hex tiles be inside a single actor, and let them be procedural mesh components. Let's look into this first. Yeah, these are all user defined: grid width, grid height, hex size, and orientation. And in the class implementation, you have the default value. This is perfect. Okay, so let's create the plugin now. All right, so let me implement the actor classes starting with the hex grid. And now I just have to copy over the header files. I need this struct and the class itself. Now we need to just add the procedural mesh component in our build.cs. I also need to copy the hex grid class. Everything looks fine. I have also fixed some of the compile issues. Alright, so over here I will be testing my tile system. Let's add a blueprint folder, and this is going to derive from the hex grid class. Let me add this over here. And for the generate grid, instead of making it blueprint callable, I will make this call in editor so that it's available via simple button. So now I need to look for the options over here. Yeah, here you go. Generate grid. I think it generated in the reverse order, and we need to fix that by just reversing the value of the triangles. It will be 210, 320, 430, and 540. All right. Only single grid is generating. Yeah, so this might be an issue. I will just need to tell Claude that this is an issue I'm having. I will just add a new chat because I don't want to confuse it. Because it already has the content, so it doesn't need to be again spoon fed everything. I will just say only a single hex grid is generated. Alright, so here you go. I'm getting the perfect result now. So the hex tiles are rather looking like a continuous mesh, and that is because currently they don't have any padding. So I'm going to ask Claude to add some padding. Yes, this is absolutely marvelous. Yeah, if I change this to flat top, yes, this works perfect as well. And for odd offset, even offset, yeah, they all are perfect. And I can also set custom material. So next we are going to create the battle armies and place both the player and the enemy units on the corresponding grid tiles. I removed the previous chats and I have added the updated files over here. Now I'm going to start a fresh chat. We are going to implement the battle system where both the player units and the enemy units will have multiple different types of characters, and each of them will have its own animation, skills and attribute systems. We have the battle grid, so we can spawn the battle manager on the level and we will add the battle grid. Then this player units is going to be added. Let's say in the actor only I will have the player units and the enemy units. What I wanted to modify is this one unit type. I want it to be a custom data asset instead. And I also want to make use of the gameplay ability system. I really liked the way it designed the entire battle system. I could not have come up with this myself, at least obviously not in few hours. My way of thinking is quite different than how Claude is thinking, so I don't think my approach would have been better than this. I don't have the experience with the game playability system, so I am asking it to create that for me, because if it was up to me, I would have taken a lot of time to understand how that works. But I don't have to now. I immediately look into the code and I can understand, okay, this is how it is working right now. Now let's implement the unit actor. I'm going to create a new class of the type pawn. You have this unit data. I will add it over here itself. Now let's create the unit factory class. Okay, so finally we are going to implement the battle manager, which is the actor that we are going to place in the level, and entire system is going to be handled by that, including placing units and deciding whose turn is going to come next. Now let's create the data table of the type unit data. Here we are going to add all our unit actors and their corresponding properties. So I need to get different types of characters over here that can be useful for demonstrating how the turn-based battle system is going to work. And the Paragon characters, which are part of Epic's free contents in the marketplace, works really great in demonstrating this kind of battle system. So I will be downloading a few of those. Meanwhile, while they are getting downloaded, I will work with the third person character template itself just to see how the placement is working. Currently, our code has been set up to detect a particular unit by its row name. So we are just going to name our row as simple as unit 1 and 2 for now. The main function over here is this initialize grid function, which is a blueprint callable. So in our blueprint, in the begin play, we are going to call this function. So it took a while to load, which is not desirable. We need faster performance, and also I can see that the enemy unit is not placed at the right location. The player unit is correctly placed. So let's ask Claude to fix these issues. Alright, so it generated all the code that it needed to modify in order to fix these issues. Okay, so here you can see it is using the streamable manager class for asynchronously loading all the assets. That is quite smart, I would say. It is going to be much faster. Finally, we are going to update our battle manager class, which is possibly going to fix the offset issue. Yeah, the enemy unit is now rightfully placed. Also want to check with the event offset. Yeah, looks more or less fine. Except with slight offset that you can see for each of the units, they should ideally be placed at the center of the respective hexagonal tiles. That is basically because the hexagonal tiles are having a padding set, but the code is probably not considering the padding while placing the units. So I'm going to fix that now. Okay, it is better now. The characters are placed exactly at the center of the respective hexagonal tiles. The Paragon characters are now downloaded into the project. Let's update our data table and add all the downloaded Paragon characters. So here we have slight offset for the enemy player positions, but the player units are correct. So I will ask Claude to fix this issue as well. Yeah, so this is much better. Also, I want the units to have some randomness regarding the positions where they are being placed. Okay, so you can see that the units are not always exactly side by side to each other, and they are maintaining a random distance of one hexagonal unit on either side of the placement. Alright, so this concludes our basic placement logic for the player and the enemy units, and this was pretty faster considering this is a pretty damn awesome prototype of a final gameplay provided you are making something like this. And if it were up to me just to come up with this code, I would have taken at least 1 week. So this is pretty faster for me, and it really helps me quickly iterate on the issues, give the follow-up prompt to Claude so that it can understand what is going on, and it can also suggest some solutions, and some of them may work, some of them may not work. And then if you're an expert with Unreal C++, of course you can fix them yourself, but even with that 90% of your effort is already being solved by Claude, and this is just going to get smarter and smarter with time. Now let's design the player pawn, which is basically going to be camera that will be orbiting around the hexagonal grid. Alright, we have got a basic structure of the battle camera pawn class. Let's create this class in our project. As usual, we are going to copy this entire class structure, both header and CPP. Here you will find that Claude has given the outdated input binding system that we used to use in Unreal 4, but now with Unreal 5 we are using enhanced input system. So I will ask Claude to modify the existing functionality so that we can integrate enhanced input system here as well. We also need to create the input assets, namely the input mapping context, which holds all our input action mappings and the individual input action for each of the respective actions. If you're interested to know more about the enhanced input system, I am working on a tutorial on dynamic key binding, which is going to use Unreal C++ to dynamically rebind your key map using the enhanced input system, and it also covers the basics. So please subscribe to my channel so that you get notified when it is updated, and I will also add the link in the description of this video once it is published. Here I am adding some of the common actions that I can think of for a typical turn-based camera pawn. So here basically WS, AD, Q and E are responsible for movement along all the three axes. And then you have your look around movement with the mouse XY axis, and also zoom in and out with your mouse wheel. Let me now create the blueprint class for the turn-based pawn. In the class defaults of the blueprint, I need to add the default mapping context along with all the input actions that I created. I am also calculating the center of the hexagonal board at begin play and adding the board center variable. That is because this is where I want to spawn the turn-based pawn initially. Alright, so this is working as expected. I can move around with WSAD. I can also rotate the camera with my mouse in both the direction along X and Y. And finally I can zoom in and out. So that wraps up today's video on getting started with creating your turn-based battle system using Claude 3.5 Sonnet. I plan to continue this tutorial series as a step-by-step guide allowing you to follow along and gain a solid understanding of Unreal C++. Developing a basic to intermediate knowledge of Unreal C++ will be incredibly valuable for you, especially when using generative AIs to help you write the code. The project files are available for download on my Patreon page, so please consider supporting me by becoming a member. And if you enjoyed this video and want to see more tutorials like this one, don't forget to subscribe to my channel. So that's it for today's video. I will see you in the next one.